And as an introduction, my name is Jane Paek, and I manage the solutions architect team at Redis Labs. For those of you that are not familiar with Redis, we're an in-memory database company. So it's kind of a question of like, why would a database company be talking about APIs and rate limiting and metering? So I'll get into where APIs are used, especially the concept of metering around APIs, and then get deeper into the algorithms, the logic that you need to break up into identifying the different components of doing the rate limiting metering, and how it's relevant to capturing that information within the database framework. Okay? And just to give you a quick background, I come from a double E degree. I've been in the industry for close to 20 years. I started at Oracle, migrated into different enterprise software technologies, and landed at Redis just because it's a foundational technology which is prevalent across the industry on, where people really need fast access to data, and in these days it seems to be everywhere. Okay? So what are we going to cover today? The main theme of today's presentation is about protecting and scaling your application through rate limiting and metering. And typically it's through the concept of APIs. So we'll get into what is rate limiting and metering and where it's typically used, what are some of the use cases and design elements that should be considered. We'll then get into why Redis for rate limiting and metering, what are the components that are relevant for the type of things that you need from a programming perspective as well as from a design perspective, the traits that you want to actually create within your own application versus things that you want to leverage that's outside of your development, where there are tools or utilities available to handle some of the broader logic that needs to happen very quickly when you're doing rate limiting and metering. Some of the patterns, and I'm going to cover just broadly more of the simpler patterns, and hopefully you get a concept of what are the basic patterns and how you could leverage those patterns to overlay and add complexity to what you have. And then I'll give you a really short rate limiting demo that one of the members of my team created, and then finally resources that are available to you to dig deeper and learn more about how do you go about creating these metering and rate limiting algorithms within your organization. Normally, this is where I would ask, who's actually written APIs, what type of APIs have you created, what technologies, what languages do you use, as well as whether you've used any back-end databases. So I may not be able to ask you directly, but if you want to put some comments in chat, I'd love to review it afterwards just to get a perspective of who I'm speaking with as an audience. So let's talk about metering and why it's important. Because you may not know it, or maybe you do, but metering is everywhere, especially in the digital world. And so companies typically bifurcate their concept of metering or rate limiting into two different business reasons. One is around revenue growth, and the other is around risk mitigation. So what does it mean for metering around the concept of revenue? So you have touched many services where they talk about a pay-as-you-go concept, a premium concept where a little bit is free, but then to get the extra service, you have to pay extra, or tier pricing where, depending on what your utilization requirements are or your company's utilization requirements are, you may have a small, medium, large type of pricing requirement. So for all of those cases, as a company who wants to track revenue, or as an individual who you're starting a company and you want to define or identify what type of services you want to provide, ultimately, you need to figure out, well, how are you going to measure and track the consumers of your resources to determine what the revenue conversion is going to be? Or even, it may not even be tied to revenue per se, but it could be user adoption or understanding a trending of how is somebody using your service so that you could provide a better service around it. Okay? So then the other side of the coin is, versus revenue growth, is around risk mitigation. And this is a key topic that many web services are focused on, especially as there's a lot more users on the internet and there's a lot of vectors in which they're using your services, be it mobile devices, on your browsers, on your laptops, on your computers, internally inside the company or outside the company, and so on. in the cloud. There's multiple ways in which people are consuming your services. And so they look at ways of identifying, well, I have a limited resource behind my API, and I need to figure out how to shape the traffic that's coming in and going out. How do I identify from a security perspective who I should allow or disallow? And also limit the user from the view of, I have a limited resources for a window of time, and I'm only going to allow you X amount to consume within that window of time. Okay? So from a risk mitigation standpoint, there's many, many reasons why you want to protect your resource. And so that's another area where you want to be able to figure out and identify the consumer, the resource, and how you want to break down the resource consumption itself. So just to strengthen that point, well, what happens if you don't meter, or if you don't limit the rate in which your resource is being consumed? And by the way, when people talk or people view the concept of rate limiting from the view of bad actors doing bad things to a resource, and you want to limit their access. But often that is not the case. Often it's the unanticipated use cases where a new release of a product comes out and the developer realized, oh, I thought my resource would be consumed at 1 minute or once per minute or 10 times per minute. But the new code that got released, it's checking every time that API gets called, and it's like 10,000 times a minute. So between unanticipated use cases of where the users that you thought they behaved one way, but it's different, or programmatic errors where one particular new release is triggering a whole flood of requests into an API that you're not aware of. So there's many reasons in which the users who are going to access your API are behaving in a different way than you had anticipated designing the access to the backend system. Okay? So in those scenarios, you have a user that tries to do something, and they're kind of like blowing up on the access, right? So the load balancer is redirecting, it sends it to, again, it depends on how you're layering your API layer at the application level. Some people actually create a whole separate API checking service. So it goes through, it then your APIs typically are a layer in front of a backend or a backend resource, right? Things like a MySQL database, a relational database, a document source, a search engine like Elasticsearch, Redis search, a graphical database like Neo4j. But regardless, your APIs are front-ending some sort of a back-end resource. So all of a sudden, you're throwing so many requests into a back-end resource, which is not capable of handling the volume of calls. So it then blows up, and blowing up from the sense of it crashes, or it has memory issues, it has CPU issues, and it is not able to handle the number of requests that are coming in from a problematic user. Okay? So then it has cascading effects on all the other users who were trying to use this properly. And then it blows up, you get unhappy users, upset, they're cranky, they call, you have revenue impact. And so there's many, many reasons why there's casualties around not protecting your back-end resources sufficiently if you are not able. So I'm going to pause for a second. Feel free to add questions into the Slack or into the chat, and I'll follow up afterwards if you have specific questions around this topic. Right? So let's take a step back. I've identified where metering and rate limiting is relevant and useful. And by the way, for the APIs that you have touched, there's companies who just focus on APIs, right? You could have a application running in your company, running in your service, running in your startup, and you can say, well, I don't even want to handle this layer of APIs, which includes authentication as well as rate limiting. And these rate limiting companies use these algorithms, and they cache and store all of this data about who's accessing what and how, typically into a Redis database because it's so fast. And I'll get into that piece of it later. Okay? So let's look at from a design aspect. If you are going to meter and rate limit, what are the typical areas that you need to clarify? The first one is who. Like, who are you actually going to identify as the consumer of your API and your resource, right? So A lot of people use API keys, JSON web tokens, or IP addresses. So the identification of who is really critical because it determines the granularity of the identity of the user. Okay? So some people have a waterfall way of identifying the user, point from a very granular level of the individual, tied to the device, tied to the application or IP address, depending on how you're planning to measure, meter, and charge for rolling up to the users that they're consuming. Okay? The other middle one is the how pattern of it, right? How do you go about determining, whether the user should have access to the information? And so that gets into this discussion of, you've identified the who, but how are you going to track the individual? Typically, there's a timestamp involved. How do you identify whether a timestamp is allowable or not? And the resource, or how the frequency in which that resource should be consumed and how much they've already consumed. So there's some historical artifacts that you need to consider, right? And then the other question is, well, if the user appears, they use the resource, and then they disappear for an hour, do you really want to keep that information? Because that retention of information also consumes resources from the data store that you're storing all of the metrics. Okay? So the who and the how is very programmatic. You as a developer have to consider, and you could work through as part of your development design team, who you're going to identify and how you want to capture and logically define the resource consumption. And then the last place is the where. And so the where piece of it is, where do you want to store all the data that you're tracking, all the identity of the users, all the time windows in which they're supposed to be consuming the information, as well as the specific resource constraint that they're supposed to access, how many times they've already accessed, and whether you should allow them to consume the resource or not. Okay? So all three factors should actually be decided in conjunction, because the choice of the who and the how and the where will determine the tech stack that you choose. Okay? And specifically around the data store, I'll highlight some of the key attributes specifically around Redis, the database, and what attributes you could exploit or you could leverage to offload a lot of the logic that you may not want to actually retain within your application or API data. All right, so let's talk about Redis. And as an introduction, I mentioned briefly that I manage a solutions architect team at Redis Labs. So we are the home of open source Redis, but we also have an enterprise version where we allow customers who previously deployed in open source, at some point they hit scalability, high availability issues, or typically design issues around scaling their application and hardening it to be more production ready. Okay? So Redis as a technology has been created since 2009. People typically come to Redis mainly for performance reasons. And when we talk about performance, we're talking about the scale of milliseconds, right? Our customers ask for, hey, I have an application. And by the way, Twitter, Uber, Groupon, there's multiple different customers that we have on the enterprise space, and a lot of them in the financial services area, where they're getting volumes of people constantly accessing their system, 100,000, a million operations per second, and the request is the operations need to be performed at less than millisecond latency. Okay? So imagine the scale of APIs where all these requests typically go through APIs, and those APIs need to be responsive, regardless of the authentication and the meeting that needs to happen. The fundamental nature of APIs is to provide some sort of a response back to the user, right? And so that response may be partitioned into not just the authentication of the rate limiting, but all the times behind. But all of that response time back and forth from an API, typically end users are not happy if it's done over 100 milliseconds, right? So the requirements from the industry for a lot of these services, the desire is to have response time less than 100 milliseconds. And so in the point of accessing data, you want data access to be in the ranges of, a lot of people tell me it's less than 10 milliseconds. Specifically to Redis, we're talking about less than 1 millisecond latency. Okay? So performance is one of the key reasons why people come to Redis. But with performance comes with a number of data structures which make it very database friendly. So you could have a key value store, you could have hash maps, sets, sorted sets. There's a number of data structures that I'll get into deeper into about what's interesting and why it's relevant for rate limiting and metering. But the simplicity aspect of the data structures in Redis are really cool for developers. And then there's extensibility. You could write in EULA for more of an atomic type of call if you have multiple command calls. There's also ways to extend it via modules. The net of it, Redis is an extremely popular in-memory open source database. And most recently in the 2020 Stack Overflow survey of all the different hundreds of thousands of developers, we are, again, the fourth year in a row, the most loved database. And talking about scale, we hit more than 2 billion Docker downloads as of, I think, this year. And last year, it was 1 billion downloads. So the scale in which people are adopting Redis, mainly because of the whole microservices shift, is huge. Okay? So that's a context of why Redis is a very popular database to store information regarding rate limiting and metering. Okay? So what is it about Redis? So what are some of the traits that make it interesting? So I described some of the use cases where users come in and the volume in which they're accessing your APIs, sometimes it's variable, especially in this COVID situation. We had lots of customers where their volume of traffic increased 10x of what they normally had to handle for Thanksgiving or Black Friday, right? So in terms of the access to the information, especially around rate limiting and metering, the ability to scale and burst to hundreds of operations a second at sub-millisecond latency, there are very few data stores that can handle both the scale and the latency in terms of how you can provision for your app APIs. A fast centralized data store for the resource limit at the state, and I'll talk about a little bit about like storing the state in Redis. Optimize commands so that it's really easy on the developer side to quickly say, okay, like another resource request has come in, how do I quickly increment or decrement the resources that are being consumed? The granular control of the resource lifetime. So this one's a little bit subtle. So I touched upon it a little bit around identifying a user. The user comes in and they ask for a resource, and that's it. And they made one request at the top of the hour, and that was it. And so should you keep that user's information for a very, very long time? Or should you set a time to live and expire the user if they haven't used your resource after 1 minute? Okay? So the granular control of the resource lifetime, if you had to try to keep all that information at the application layer, that level of detail, the level of control can be very expensive at the application layer. It's expensive both from development costs as well as from resource consumption costs. So you may want to offload that type of control into a distributed database where the database keeps control of the data, but also handles the expiry of the lifetime of that data. Okay? And then you could also add in database analytics for identifying the leaderboards, like which resource is consuming, or which user is consuming the most resources in this window of time, or the ranking and the scoring. By the way, gaming industry loves this feature of Redis, the concept of using a sorted set to identify leaderboards and ranking, but we could definitely use it in the analytics part of your resource consumption for rate limiting and metering. Okay? And then I described it a little bit, but flexible data structures to meet different metering designs. So I'll touch upon a couple of those. Okay? So the Redis data structures for metering and rate limiting, the main ones that I'm going to cover are strings, hashes, lists. Actually, the main ones I'm going to cover are strings, hashes, and sorted sets. But the ones that I really like are lists and hyperlog laws. So there's multiple different data structures within Redis that accommodates for different design patterns for rate limiting and metering. But these are the ones that we could highlight. Okay? So given we have these data structures, what are the commands that you could issue to be able to increment or decrement a key, or expire the lifetime of that key, or set the time to live for, or check the time to live for a key? Okay? So I wanted to show you something really quick. Some of you may have used Redis before, some of you may not have. Redis is super easy to develop against. My apologies, my door keeps on opening. But you could download a Docker image on your MacBook. I believe there's an image for Windows. Redis for Docker, but Redis in general is very, very happy in the Linux world. And I spun up a Redis server process. And now there's a Redis CLI that I can log into. The default port is 6379. Okay. And we also, so this is on my Mac terminal. I can log in. We also have the ability to be able to, we have a UI, a web UI that can log into the Redis database, and you'll be able to issue the Redis commands. So I could do something as simple as set name Jane, set name comes back as Jane. I could expire the word name, right? Expire name, I could do it in 10 seconds. I could check the TTL for name, and it goes down. Redis is constantly checking for the life of the key. And if the name does, if time expires, into a -2, and if I could do a get name again, it factors nothing, right? So in terms of the way you handle keys in Redis, you could set a key, expire a key, and let Redis handle all the clocking of the time expiry. And you on the application layer, your only focus is to set the expiry and keep on extending the expiry as necessary. Okay? The other aspect is the incur and decur. So remember, metering is all about identifying who's coming in. Do they have access to the resource? And if they are getting access, then you either need to determine, should you give them more resources, and should you actually keep track of the number of times they have been accessing your resource. So that's where the incur by commands come in. And these apply to a regular string. These are both string increments, and hincur is for hash keys, and the other one is for sorted sets. And I'll get a little bit deeper into this a little bit later. Okay, you can also decor the command. So for example, imagine the speed in which these API requests come in. I could do just incur my counter, right? And then I could keep on going. And so this is it. If your application just, all it does is take a request coming in, hey, users identified or made another request. All you could just do is incur and incur. If you didn't want to limit anything, you just wanted to incur, this is it, right? And so these are all one operations, ultra fast. So if you have 1 million users all coming in and they're constantly asking for more and more and more, if you just want to track what an individual user is asking for, this incur command is extremely powerful. Okay. And then the same thing gets reflected on the decor command. Okay. So rate limiting design considerations, something to consider. Rate limiter is a tool that monitors the user request in a defined time window. So a couple things. Identifying the users. Remember, users can be both humans or services. So you want to be able to qualify how that service is uniquely identified in your tracker. You also want to identify the requests that are coming in the window of time. Are you going to limit your request within 1 second, 1 minute, 1 hour, 1 day, 1 week? And do you want to have roll-up capabilities on defining the window? Because we have some people who are saying, I want max abuse of my API 10 times a second, but in a minute, I want them to have a max of maybe 30, right? And then in the hour, I want to have a max of maybe 300. So there's what you want to be, you could actually roll up your defined time window, but that adds a layer of complexity on how you want to gate that resource. So be careful of complexity, be careful of data usage. Some of the choices where you want to monitor a user, every time a user accessed it for the last 2 years, imagine the amount of storage required for all the millions and millions of users who are coming in and how you're going to retain that information in any kind of database or at the application level. And the granularity of the tracker itself. Okay, so remember, one size does not fit all. And the other thing is to do is consider over-limiting behavior. So couple of things, and I'll give you just a visual example of how some of these may work. So in this very, very simple example, we have a simple fixed window counter using a string. So remember, a string from a data structure standpoint is a key and a value. Okay? So in this case, this string is all of this, right? So we have a user, the identifier, and the window start time. We have, the user is actually the word user. The IP address could be my host name, and then the timestamp could use an epoch timestamp that we set up, right? So you identify the user, and then you could set the user to say, hey, when the user makes an API call, does this user exist? And if so, create the user and set up an expiration window. Maybe you only have 40 seconds left in my one window time frame. Starts at 10 o'clock. You have until 10 o'clock, 1 minute to actually use up, 5 calls within this time interval, right? So if it doesn't exist, you create the key and you increment the value. If the user does exist, then you increment the value because this is the value, is the number of requests that they make. And then check, is the key value over the limit that you've set up? And then you have a decision tree of no or yes, allow or yes. Okay? So in this example, here's my 1 minute interval, no request at this point in time. User comes in, user 1, at time 0. And then because they came in at 20 seconds into my minute, I set the expiry to 40 seconds. And then the number of requests that the user made was 2. And we allow the user to go through because our fixed window is 5 requests per minute. Next one is that user comes in. By the way, Redis expired the key because 1 minute has elapsed. The next window, we create the user again, add their requests. And then at 1 minute 30, they made 3 more requests. They're allowed because they have up to 5. Now the TTL is 30. And then at 1 minute 50, they're abusing the request because it's at 7 versus 5, and they get an over, and they get a, either an error saying abuse, or you'll get, you should send some sort of response or a non-response. It really depends on the type of API that you're restricting, but this request is not allowed. And then back at 2 o'clock, it's reset back to 0 because expiry is set. Okay. One thing to watch out for, fixed window. The issue with fixed window is that notice between 1 minute 30 to just past 2 minutes, 2:15, I allowed 7 requests to come out, even though technically I only wanted 5 per minute. Okay, so this is where fixed window is not great, in that you could get bursty behavior if everyone wanted all the requests at the front of the hour. So imagine if somebody did it at 1:59, 5 requests, and at 2 minutes, they did another 5. You allowed 10 requests to come in within a 2-second interval. Okay, so that's one of the issues with the fixed window. The alternative is a sliding window. And so the sliding window is that you could have a previous minute, current minute. So a sliding window, you've already had, in this example, it's 10 requests per minute. I had 5 requests already in the past, previous minute window. And then in the next two requests, since I already had 10 requests in a 60-second window, I would have rejected these. In the next cycle, these 3 are no longer valid. And so when the next request comes in, my look back is, oh, I only allowed 9 requests to come through. Is that right? 9 requests to come through. So I'm going to allow the next request to come through. Okay. And then the next sliding window, the other 2 had expired. These 2 are allowed to make the request, but then the last request is blocked. Okay. So the sliding window, differently from the fixed window, uses a sorted set rather than a string. So the concept of a sorted set is you have a user and you have a score and a value. And in this example, the score and the value are identical, and they're a timestamp. So what it's really tracking is anytime a user makes a request, I'm going to store the time in which they made that request into my sorted set. And by the way, sorted sets, the number of members, it could handle millions and millions of member value pairs for that one key, right? So for a given user, the first time it requests, you create the key and you add the timestamp as value and score. And then as the users continue to make the request, you as a developer will just say, hey, what is my current timestamp? Let me remove my old timestamp values because they're not relevant. And then you do a quick look back to say, how many unique requests do I have for this particular sorted set or this user? And if it exceeds 10 for my minute, I block. If it doesn't exceed 10, then I allow it to happen. Okay. So this is a concept of a sliding window where for a given user, you're creating a sorted set, but that sorted set is keeping every single track of the timestamp of the requests that come through. So you're always truncating the older ones, and then you're counting up the cardinality of the requests that came in currently. Sliding windows can be, not even can be, it is very accurate because you could get to the exact number of counts or requests that the user has done. However, it could be memory intensive because if a user or an API call starts calling 1 million requests, you are still tracking all the 1 million requests in that window of time. So the bloat capability of this sorted set could be very, very broad. Okay, so key things are to make sure to expire and extend the expiry of the key when the values are added. So token bucket hash is another one where you almost have like, you're pre-allocating the tokens for the user, and then as a user consumes the resources, the tokens get decremented. And so in this concept, the data structure that you're using is a hash key, and the user itself has multiple. The user key is a hash, so it has multiple field value attributes. So you have a timestamp and a value, and tokens and a value. And so as the users start consuming resources for that time window, you either could add more tokens or you decrement tokens based on your consumption. Okay. The one thing to keep watch out for this behavior is that you're constantly having to check and set, which means multiple calls to validate the state of the key or the user and the response. So this is where some of the race conditions come in, because as one user using one device does a set, another one could have done a get and a set. So there's a race condition that could occur for that one particular key. Okay. So some of the anti-patterns you should focus on. I talked about rate conditions.
Sorry to interrupt you. Just want to quickly check in. We are already over time, and I want to see if you want to take some questions instead, if you would like to.
Let me do that.
Okay.
I really want to show you my demo, but here, this is a drink demo. You could actually have it for what incremental drinks. You could do the Jaeger bomber and see the number of accounts that are happening into Redis, but I'll stop. And by the way, I'll make all of these resources available afterwards. The slides will be available so you can review. All right.
Okay, great. So I just want to, there are a couple of questions on the chat, and maybe you could help us answer them. So the first one is, do we set the rate limiting rules in Redis so that it blocks a specific IP or user with token, etc., and then it's set or forget? Redis will take care of all of it for us?
No. So the answer is no to both. So Redis is a database, and it has a couple of attributes that allow you to increment data and decrement data and keep the lifetime of the data, like expiry and setting. The logic of what happens on, what is the resource? Should I make it 5 API calls per minute or 10 or 100,000? And identifying whether it's an IP address or a token, all of the logic around the resource constriction, that has to be done at the application layer. However, there's lots of resources and examples of people who've written it in Python, in Node, in C, lots and lots of different examples. And the one thing that you may want to go to is redis.io. So in there, they talk about different client libraries that you could use. And a lot of people love Python, but honestly, most of my customers tend to be Java. So they use a lot of Redis and Redis client libraries. So take a look at redis.io, and it will give you examples of how you think about a rate limiting option. I find it kind of like narrow in view, but at least it will help you get started. Okay.
Okay. Awesome. There's another question. Can Redis be used for internal rate limiting? For example, I'm sending a mail through the log API, but with my plan, I can max send 5,000 requests per month.
Okay.
Does it help me track my request numbers so that I don't go over?
So you could, as part of the access to your resource, you could use Redis as a quick checker. Say, hey, you are over your usage limit, but somebody, you or some developers will have to programmatically store that information into Redis and access it. Okay? But in terms of using Redis to gauge and determine, and by the way, you could use Redis anywhere. People have used Redis in a Raspberry Pi device, right? As on the IoT systems. I mean, it's really fun just taking a look at the use cases for Redis. One person, they're doing all the biohacking. So he wrote a sensor that takes your brainwaves. For every timestamp, your brainwave changes. And they store it in Redis to see what the time series differential is, right? Or stored in a graph database built into Redis. So many, many different ways in which you could store super fast data in Redis, internally or externally. It doesn't have to be specifically on the cloud or in your Linux server. It could run anywhere you want. Okay?
Okay. I think this is one last question. Can you set different rate limits for different times? I'm thinking that if you see that usage is low at certain windows in the day and you want to let more requests per user during that time.
Absolutely. So again, this is all programmatic on how you design your rate limiting concept, right? And that's the fun and the risk of it, because when you start, a lot of people start with like a really rigid format. I'm just going to do a fixed window, or like get a little bit more sophisticated, like, let me do a sliding window. And then they realize, ooh, I want to be a little bit more sophisticated and use a token, right? A token bucket. And then they overlay on top and say, like, I actually want a leaky bucket, or like a concept of the two. And so depending on what your program wants to do, based on the throughput that's happening within your API, so you may have you know what I like? There's this like thing called a hyper log, and a hyper log allows me to count unique things. So you could use a hyper log as a super fast counter of unique activities. And it only uses 12 kilobytes of memory, which is like shockingly fast, right? And so you could use that to determine like how many unique requests came in the last minute or in the last hour. And based on that value, you could change your rate limit tolerance. Okay? So yeah, it's just this concept in itself is really fun and sophisticated. I remember listening to Box present about how they do rate limiting, and it was pretty cool, the algorithm that they use.
Cool. Sounds good.
Any other questions?
Thanks a lot. Yeah, I don't see any other questions on the chat. Yeah.
Okay. Well,
if you have any other questions, then maybe you can reach out to Jane offline as well later if any of the participants want to have a conversation about something.
Yes, let me just put this into the chat. My email is jane@redislabs.com. Feel free to email me if you have questions. By the way, we do these seminars often to a number of different webinars and so on, so feel free to join. And then Redis University, tons of resources for you to learn for free. Okay?
Thanks a lot, Jane. It was a really great and informative talk and an apt end to our sessions today. Thanks everyone who could join us today for the talk. And we have our last keynote session that is going to be happening at 4 p.m. So please head over to the stage area and please feel free to share your thoughts and we are also going to be having our next couple of events on the upcoming Friday and the Friday later on the 12th of June and on the 19th of June. So don't forget to join us as well. Thanks a lot, Jane, for your time as well as for sharing your knowledge with the community. We appreciate you and we hope that you continue to be involved with Women Who Code and we see you speak at further events as well.
My pleasure. I'm sorry we're out of time. Next time I'll do it shorter or longer. Thank you.
Sure.
Bye-bye.
Thanks, everyone. Bye-bye. Have a great weekend.
You too.